Hi, everybody. Today is our second statics class, and we are working through lecture number 2, which is going to involve using the shared document that we have about unit conversions. So first of all, I just wanted to remind you that this is a homework assignment, and it will be due on September 1st, which is next Friday. That really gives us ample time, but part of that time is to make sure that you understand how the homework needs to get submitted, to make sure that Moodle doesn't give you any problems, to make sure that, like I said, that you submit it in a format that I can read, which is almost anything except for an HEIC file, but just all of those different things. So that's why we have a little bit of space before that becomes something that we have to do. All right, so as far as this work goes, just remember that everything is available to you here on our statics page. We have the syllabus and we have the homework template, which will show you how you should do your homework, what it should look like, more or less. We also have an example of what engineering composition paper is. And as we discussed before, if you are physically in Powell, I have tablets of engineering comp paper, and you're welcome to come get one from my office. I'll also always try to leave tablets or some paper outside of my office so that if you need it, please help yourself. If you have a tablet at your house and you just don't have enough to do your homework, please just take enough to do your homework. You know, don't, if you're here, but just do whatever you need to make sure that you have that paper and you don't have to waste any time looking for it. All right, so as our schedule shows, today we have the option of either face-to-face or Zoom, or we always have the option of asynchronous learning. So you can always patch in with the Moodle page, this lecture and all the others will be posted up, and you'll be able to see them as soon as they are made available by the system. Now you can see on Monday, Wednesday, and Friday of next week, I don't have the mode that whether we're going to be face-to-face, Zoom, async. You'll always have async. The face-to-face or Zoom, I will put those modes up so that you'll know. And mostly it's just some of the time I'm not going to be having class in this room. It's not that often, but if I'm not in this room, then it would only be Zoom or async. And occasionally we will only have async. All right, so I wanted to take a look at the unit conversion sheet, and I just kind of wanted to go through a couple of different points that may seem, some of this may be familiar to you, or it may not be familiar to you. So we're going to take it right from the beginning. One thing here on problems 19 through 24, we are using two conversion formulas. These are from degrees Celsius or centigrade to Fahrenheit and vice versa. So the thing that I would like to point out with these formulas is, if you notice, the Fahrenheit formula does not have a parentheses. So in other words, you do the multiplication first, and the Celsius formula or centigrade formula does have parentheses, so you do the subtraction first. So coming back over here to our screen, if you were given something, for example, and it said, what is 50 degrees Fahrenheit in degrees Celsius? You would take 50, subtract 32, which would give you 18, and then multiply that number by 5/9, and that would be 10. So in other words, 50 degrees Fahrenheit is equal to 10 degrees Celsius, okay? Now, going the other way, you would do the multiplication first. So if you were given, I'll just show you this one because it's kind of something you should maybe, well, it's just kind of a funny thing. But let's just say if we have a negative 40 degrees Celsius, if we plug it into this formula, we would get that the Fahrenheit would be equal to negative 40 times 9/5 plus 32. And when I take this is 8. 9 times 8 is 72. So that would be negative 72 plus 32. And so the degrees Fahrenheit is minus 40. So that was the piece that I wanted to show you, is that negative 40 degrees Fahrenheit is the exact same temperature as negative 40 degrees Celsius. Okay. And one, there's a sort of a lame joke involved with that if it's 40 below zero, it's just really cold. It doesn't matter how you measure it. So there you go. But that's where the two scales have the same basis, is at negative 40. Okay. And then a degree Celsius is bigger. So if you think about this, if you look at Celsius is based on a scale of 0 to 100 for water freezing and water boiling, and that's at 1 atmosphere pressure. The temperature at which water freezes, and more importantly, the temperature at which water boils, changes a little bit if the pressure is different, but at 1 atmosphere pressure, standard atmospheric pressure, 14.7 psi, it freezes at 0 degrees centigrade or Celsius and boils at 100. On the Fahrenheit scale, water freezes at 32 degrees and boils at 212. So one thing you can see is they don't have the same zero, right? So they're not, this is referred to as an ordinal scale rather than a cardinal scale. Cardinal means something, absolute means something. Okay, neither of these really does. These are even just reference points. But 212 means that Fahrenheit, the size of a Fahrenheit degree is much smaller than the size of a Celsius degree. So just to finish off this thought, there is an absolute temperature scale, and that is based on the idea of absolute zero. And what absolute zero is, there's a lot of kind of fantasies about what absolute zero really means. But what it really means is this is the point where the entropy of a perfect crystal is a minimum. So some people say it's a temperature you can't go below. Probably is a temperature we can't go below. It appears to be approaching it asymptotically in the lab, but going below it just seems like a theoretical and empirical impossibility. But so absolute zero, there are two scales. One is the Kelvin scale, and the other is the Rankine scale. And so Kelvin has the same size of a degree as Celsius, but the zero is absolute zero. That means, and this is about 273 degrees Kelvin, and this is 373 degrees Kelvin. Okay, so on the Rankine scale, absolute zero is the same. So in other words, 0 degrees Kelvin is equal to 0 degrees Rankine. And you do not use the degree symbol for Kelvin. It's just 0K. I can't remember if you use it here or not. Anyway, and then you have two other numbers. I think it's 459 degrees. I believe it's 459 degrees Rankine, and then whatever that is plus 212. But so these are absolute scales or cardinal scales, and these are ordinal scales. All right, just a little more information for you there. If we go back and look at our, I want to go back and look at our handout, just a second. There it is. All right, so we talked about the idea of a unit conversion, and we said that basically it's called unit. Unit just means one, and it's called a unit conversion because if you have something that's equal to each other, 12 inches is equal to 1 foot, and you put two values that are identical as a fraction, the value of that fraction is equal to 1. And you can multiply 1 by anything, and it will still be equal to the same amount. So that's how unit conversions work. The other way that it works, or the other thing is that if you have some value, so if you say you have, let's say 2 feet equals how many inches? Okay, you start with the number that you're given, the measurement, 2 feet, and then which one of these you use depends on whether the unit is in the denominator or the numerator. So in other words, here it's in the numerator. So in order to cancel, we want to use a unit conversion that has that same unit in the denominator. So we get rid of this, and we get 2 times 12, which is 24. And the only thing we have left for dimensions or units is inches. So that tells us that 2 feet is equal to 24 inches. So the first thing is you want to cancel units against each other, numerator to denominator. The next thing is, if we look at something like problem number 4, well, let's do number 1 here under rates and volumes first, and then I'll do number 4. Okay, so number 1 says 35 meters per second is equal to what? And I think did I ever do this one? I think I did this one. Yes, let's do the next one. I think I did this one on Wednesday. Let's say 550 centimeters per minute. How many equals some number of feet per second? And after that, I want to do number 4, which says 550 cubic inches, which means this, cubic inches. It's a measure of volume, which I'll show that in just a moment. And we want to convert that to centimeters to the third. All right, so let me pull this other piece of paper up. Cubic inch equals inches to the third. Okay, so going back to my document cam, my webcam, right here, we start with this one where we have 550 centimeters per minute, and we want to convert that to feet per second. Well, the way that we do that is we start with the top unit, or it doesn't matter, we start with one unit. We want to convert centimeters to feet, and then those are our units of length, and then we want to convert minutes to seconds. All right, so we probably know that 1 minute is equal to 60 seconds, but how many centimeters are there per feet? Well, you can do it in one step. You can look that up. Or you can say, maybe you know that there are 2.54 centimeters per inch. And then you know there are 12 inches per foot. Okay. So in other words, you can use multiple conversion factors to get the answer if you wish. All right. So let's start with this. We have centimeters in the top. So we want to put 2.54 centimeters in the denominator for 1 inch, right? And then for the next one, we have inches per feet. So once again, the 12 inches goes in the bottom and the 1 foot goes on top. Then we need to convert minutes. Minutes is in the denominator here. So we want to put it up here. And we say 1 minute is the same quantity as 60 seconds. And then we have a math problem where the centimeters cancel out, inches cancel out, minutes cancel out, and we are left with feet per second, which is what we were hoping for. So the numeric value, Justin, since you have your calculator, would you take 550 and divide it by 2.54, divide again by 12, and last but not least, divide by 60. 23.3 feet per second. Thank you. All right, now let's talk about significant figures here. 550 has 3 digits, but if there's no decimal place here, that means that that 0 is non-significant. So we would write that as 23 feet per second. Would be the perfect way to do it. I'm really not opposed in engineering to carry out 1 extra decimal place. I just really hate to see it when somebody puts in 12 decimals for, so, but this would be good, but this is the best overall answer. All right. Well, I'd like to do number 4, which presents another wrinkle in this idea. We have 550 square inches or cubic inches. First of all, if they write it cubic inches, what they mean is inches to the third. Okay. Square inches means inches to the second power. Cubic inches means inches to the third. This is a measurement of volume. Okay. Well, I know that 1 inch is the same amount as 2.54 centimeters. But what happens when I cube it or take it to the third power? Well, the answer is I have to take both sides, unit and number, to the third power. So 1 to the third power is just 1. and I get 1 inch to the third, but now I have to take 2.54 and take that to the third, which is, what's that value? Perfect, 16.3 centimeters to the third power. All right, now I can do this where I can say 1 inch to the third is equal to 16.3 centimeters to the third. I want to have inches in the denominator. I put inch, I want to have inches to the third in the denominator. And then if I do that math, the inches to the third cancels out. I'm left with centimeters to the third. And my numeric value would be 550 times 16.3. 9012. Very good. Okay, now this is interesting because the number of significant digits or significant figures is governed by this, which is 2. So I should write this as having 2 significant digits. Well, isn't that perplexing? We don't really have a good way to do that without scientific notation. Because if I wrote it like this, 9,000, that would be 1 significant digit or significant figure. The proper way to write this would be 9.0 times 10 to the third centimeters to the third. Okay. In scientific notation, this indicates that it's 9,000 with 2 significant digits. So the first 0 is significant. If it wasn't, I could just write it like this. That would be with 1 significant digit. Okay. So there you go. All right. So let's take another quick look at the conversion sheet. And I think we've covered everything that's going to be. Okay, one thing, let's look at number 5. I'm not going to do this problem, but I'll tell you what happens here. Liters to cubic meters. A liter is a volumetric measurement. So a cubic meter or meters to the third is also a volumetric measurement. So what you need to do is to just find the conversion factor between those two, and you can do that just using Google or whatever. So you can say cubic, and sometimes it's easier to type in cubic meters to liters. I'll pull this back up. All right. And you'll just get a conversion, which can be quite helpful. So 1 cubic meter is 1,000 liters. So that means a cubic meter is a lot, right? I mean, because if you think about it, like if you have a half gallon of milk, that's roughly 2 liters. So a cubic meter is 1,000 of those. So that's 3 feet by 3 feet by 3 feet. So that's a lot of volume. But so there's your conversion factor. You would just say 1 cubic meter or 1 meter cubed is equal to 1,000 liters. You don't have to cube anything, right? You just cancel and away you go. All right. So any questions at this point? Easy to get along with. Not the material's easy. I mean, you're easy to get along with. So, all right. So what I'm going to do then is just wrap it up for the day. Work on your homework and see if you have any questions about unit conversions. On Monday, I think we'll be face-to-face on Monday as well. So same, all 3 protocols. But I think I'll start talking about vectors, even though the homework isn't due until Friday. But that'll give you time to do that. And then, as you can see on our Moodle page, she says, look like I can get to it really quickly. Hang on. As you can see on our Moodle page, we have a little bit of time before that next homework is due, which will be chapter 2. So that's not going to be due till September 11th. So we have quite a ways to go before then, but we'll cover some ground. We're sort of working ahead in the lecture material so that you'll have a little bit of something to think about. Can start working on your homework, which is actually a good idea. And then if you have questions, you can bring them to class. We can work on them right away, and we'll move forward like that. But as always, if you have any questions while you're working your homework, please send me a text or send me an email, and I will get back to you just as soon as I can. So that is my plan, is that I hope to lecture well enough so that it all makes sense. But when I fall short, I'm available to help you at that point too. All right. All right, I'm gonna go ahead and stop recording, and we'll see you guys Monday.